Special right triangles. I'm going to go through this quickly. It's meant to be more or less a review. The first special right triangle we're going to talk about is a 30, 60, 90 right triangle. When you have a right triangle, there's only 180 degrees in any triangle. 90 degrees will be from the right, and across or opposite of the 90-degree angle is going to be your longest side. That's called the hypotenuse. The 30 is your smallest angle, and so across from the 30 is going to be your shortest side. And across from the 60 is going to be the medium side. Now, what's the easiest number we can start to work with? Well, the easiest number is 1. And so when we're working with these triangles, we start with the easiest number, 1. So the shortest side is going to be a 1. The largest side, the hypotenuse, is going to be the 2. The middle, across from the 60, is going to be the square root of 3. It comes out to about 1.73. So when we write these, we'll always write it 1, square root of 3, and then a 2. And we'll put it in that order, and it'll go along with the 30, the 60, and the 90-degree angles. So it'll look something like this. Across from the 30 is the shortest, the 1. Across from the right angle is the longest, or the hypotenuse, the 2. And across from the 60 is your square root of 3. When answering these problems, you always want to write this on the side. 30, 60, 90, 1 square root of 3, 2. It keeps it in order. Then you write down what side they gave you. Here they gave me the hypotenuse, and they gave it to me as a 10. So I'm going to write down 10. And then you ask yourself, 2 times what number is equal to 10? Because I know the hypotenuse is supposed to be a 2, but it's actually a 10. So 2 times 5 is equal to 10. And that means that 2 was multiplied times 5. So 2 times 5 is where they got the 10. What I do to one side, I do to all of the others. The square root of 3 times 5 and the 1 times 5. Square root of 3 times 5 is 5. Square root of 3, 1 times 5 is 5. Now I can finish filling in my triangle. Opposite the 30 is the smallest side, and the smallest side is 1, which was 5. And opposite the 60 is the middle, square root of 3. So 5 times square root of 3 was 5 square root of 3, and that's what we write. For 30, 60, 90 triangles, we always have the same setup. 1, square root of 3, and then 2. Here's another one. We set it up the same way. 30, 60, 90. Opposite the 90 is the 12. So opposite the 90, which is our 2 side, is 12. And we ask ourselves, 2 times what number is equal to 12? Well, 2 times 6. That means everything is going to be multiplied times 6. 1 times 6 is 6. So opposite the smallest side, the 30, is going to be a 6. And then 6 times square root of 3 is 6 square root of 3. And opposite the 60 is going to be 6 square root of 3. Here, they gave us the side opposite the 60. So across from the 60 is 10 square root of 3. And that's what we write. 10 square root of 3. So then you ask yourself, square root of 3 times what number is equal to 10 square root of 3? And this is pretty self-explanatory. We have to multiply it times 10. What you do to one side, you do to all of the others. So 2 times 10 is going to give me 20, and 1 times 10 is going to give me 10. And now we can fill it in. The largest side is the hypotenuse opposite the 90, and that's going to be 20. The smallest side is opposite the 30, and that's going to be 10. Here's another one with a common mistake. People see the 10 square root of 3 and automatically put it on the 60 because there's square root of 3 there. Don't go off the number, go off of the side. This side is opposite the 90-degree angle, so we need to make sure that we put it underneath the 90-degree angle. And then you ask yourself, 2 times what number is equal to 10 square root of 3? Well, hopefully it's pretty self-explanatory. 2 times 5 is 10. And then there's just a square root of 3 sitting there. So 2 times 5 square root of 3 is equal to 10 square root of 3. That means I'm going to multiply everything times 5 square root of 3. Now the first one's pretty easy. 1 times 5 square root of 3 is simply 5 square root of 3. So opposite the 30-degree angle is going to be 5 square root of 3. Now the next one might be confusing to some people, so I'm going to write it out. 5 square root of 3 times the square root of 3, that gives me 5 square root. 3 times 3 is 9. Remember, only multiplying inside the radical. Well, what is the square root of 9? The square root of 9 is 3. That gives me 5 times 3, which is equal to 15. So opposite the 60 is going to be a 15. And we will always see things work out this way. If the answer for the side that's opposite the 60 is a regular number, that means the other two will have a square root of 3 on it. Now for this one, opposite the 60 is the 12. And so we ask ourselves, square root of 3 times what number is equal to 12? Now, if you remember from the last problem, we saw that the square root of 3 times the square root of 3 cancels itself out to give me a regular number. So the only way that I'm going to cancel out this square root of 3 to get a regular number is if I'm multiplying by a square root of 3. We know square root of 3 times square root of 3 is 3. So 3 times 4 is equal to 12. That means I'm going to have a 4 there. And this is what it's going to look like. Is equal to 4 times square root of 3 times square root of 3 is 9, and square root of 9 is 3. 4 times 3 is equal to 12. And that's just checking our work to make sure we did it correctly. Now we know that everything was multiplied by 4 square root of 3, and I multiply it all the way down. 1 times 4 root 3 is 4 root 3. 2 times 4 root 3, 2 times 4 is 8 square root of 3. That means opposite my 30 is going to be 4 square root of 3. Opposite my 90, the hypotenuse, is going to be 8 square root of 3. Just like we said in the last one, if your middle term is a regular number, that means that the other two will have a square root of 3 on it. The second special right triangle that we're going to work with is a 45, 45, 90 right triangle. The sides for this are really easy. Since 45 and 45 are the same number, we use the easiest number we can find. We use a 1. So we have a 1, and then a square root of 2. And if you're wondering where we got the square root of 2, we got it from the Pythagorean theorem, a squared plus b squared equals c squared. Now for this triangle here, we have opposite the 45 is a 5. So opposite the 45 is a 5. That means 1 times what number is equal to 5? Well, 1 times 5 is obviously equal to 5. So then multiply by 5 all the way down. 1 times 5 is 5. 5 times the square root of 2 is just 5 square root of 2. Remember, the 5 is outside the house. That means that my other leg is 5, and my hypotenuse is 5 square root of 2 for this problem. Notice this is an isosceles right triangle. Two sides are the same, which makes them legs, because it's a 45, 45, 90. Here's another 45, 45, 90. We have 1, 1 square root of 2. Opposite the 90, my hypotenuse is 12. So opposite the 90 is 12. Well, we're going to ask ourselves, square root of 2 times what number is equal to 12? Just like with the square root of 3's, we need to cancel out the square root. So I know that square root of 2 times the square root of 2 is equal to the square root of 4, which is equal to 2. So the only way I can cancel out that square root is by using another square root. If the square roots cancel out and leave me with a 2, 2 times what number is 12? Well, 2 times 6 is 12. Now we can check our work really fast. So we know that the square root of 2, in order to get to 12, was multiplied by 6 square root of 2. What you do to one side, you do to all of the other. And I know that 1 times 6 root 2 is 6 root 2. So that means the two legs of this isosceles triangle are 6 root 2. 4 more special right triangles. These you just need to write down and memorize. I have a 3, 4, 5 right triangle. That means that if I have a right triangle and one side is 3, the other side is 4, I know for a fact the hypotenuse will always be 5. These are something easily to memorize. You should have them at least written down, if not memorized. The next one is a 5, 12, 13. That means if my hypotenuse is 13 and one side is 12, the other side is going to be 5 automatically. Then I have the 8, 15, 17. And the 7, 24, 25. Again, if you can memorize these, that's the best. But if you can't memorize them, at least have them written down somewhere. Now, here's the first example. We have two sides of the triangle. One's 18 and one's 24. Well, that doesn't fit into our Pythagorean triples. But let's see if we can reduce that. 18 divided by 6 is equal to 3, and 24 divided by 6 is equal to 4. So I know what this is a 3 4, 5 right triangle that's been multiplied by 6. So that means that 5 times 6 is equal to 30. So my answer, PR, is going to be 30 because this is a 3, 4, 5 right triangle, and that's what I would write. PR, the little line over it, is equal to 30. Here's another one, 24, 60, and again we're looking for the hypotenuse. This doesn't fit into one of my perfect triangles, so I look to see if I can reduce. Well, I know that 25 and 60 are both divisible by 5, so we'll try that. 25 divided by 5 is equal to 5, and then 60 divided by 5 is equal to 12. Well, this looks like a 5, 12, 13 right triangle that's been multiplied by 5. So all I have to do is say 13 times 5 is equal to 65. And my missing side, AB, is 65. Use the Pythagorean triples, have them memorized, and realize that there might be multiples on here. Now, if you can't figure this out, if you're like, well, that's just way too difficult, you can always go back to the old way of doing it. 25 squared plus 60 squared is equal to C squared. Which still gives you the same answer of 65.